Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Welcome to today's Natural Sciences lesson. My name is Pathuchetso Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area matter and materials. The topic is particle model of matter, and the subtopic, which is our main area of focus for today's lesson, is density, mass, and volume. Let's look at today's lesson objectives. By the end of today, you should be able to explain what is meant by density, mass, and volume, explain the units of mass, explain the units of volume, explain the units of density, understand density in terms of heaviness and lightness, and calculate density, mass, and volume. All this is sourced from the KEPS document on page 43. Pre-knowledge. This is what we have learned prior to today's lesson, which is the foundation of today's lesson. In the 6th grade, we learned about the different states of matter, which are solids, liquids, and gases. In the 8th grade, which is in our previous lesson, we learned about the states of matter. Here's our baseline activity. I'm going to give you 4 minutes to go through the question and send through your answers to 082-760-2630. So I'm going to give you 4 minutes to answer these questions, and then when we are done, we are going to go through the solutions together.
You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork.
Welcome back, grade 8. Let's answer the questions. So the first question reads, how can materials be made to change their state? If you wrote, materials need to gain energy or lose energy to change their state, that is correct. A gas condenses to a liquid when it is cooled. If you wrote cooled, then you are correct. Remember, when you cool a gas, it loses energy and then it condenses to a liquid. And then the third question reads, the melting point is the temperature at which a substance changes from a solid to a liquid. If you wrote changes from a solid to a liquid, you got it correct. Which process requires heat to be added? Melting. Melting requires heat to be added. So the substance is changing from its solid form to its liquid form. So we need heat in that process. We need heat for that process too. Okay. Let us move on to terminology. These are the important terms that we're going to come across during the course of the lesson, and they will help us better understand today's lesson. Density. Density is the amount of mass in each volume of matter. Density is the amount of mass in each volume of matter. And then volume. Volume is the amount of space an object takes up. It is the amount of space an object takes up. And then the third term, which is mass. Mass is the measure of the amount of matter in an object. So it is the amount or the measure of the amount of matter that is in an object. Let's talk about density, mass, and volume. Everything around us has density, mass, and volume, and they occupy space. I'm going to draw up a picture of the different items that we do find in our classroom. There are tables, chairs, desk, the board, the window, the door, a cupboard, a bookcase, even your school bag. It has a density. Pencil case, book, notebook, pencil, eraser, sharpener, ruler, paper, crayons, scissors, and glue. All of this have density. They also have a mass, and they also have a volume. All of these items and all the other items that you find at home as well and in the environment around you. Mass. We have defined mass as the measure of the amount of matter of an object that an object is made of. Mass is measured in the units grams, which is represented by G, and kilograms, which is represented by kg. So when we measure the masses of small objects or small amounts of matter, we often use grams, G, or milligrams, mg. So I have a scale here that is a kitchen scale that I'm sure you've seen at home or you've seen it in other places that they use to measure amounts of flour or other kinds of food when someone is baking or is cooking. So we usually use a kitchen scale, and the lab also has an electronic scale that we use to measure small amounts of matter. So we measure them in grams or in milligrams. And then how do we calculate mass? Now we know that we use a scale to measure mass, but how do we calculate mass? So mass, remember, is measured in grams or kilograms, right? So 1 kilogram is equal to 1,000 grams. And the formula for converting grams to kilograms is We multiply the kilograms by 1,000. That is how we convert grams to kilograms. Both units are interchangeable, and we have different formulas that we use to change them. And then here is an example of mass conversion. The question reads, convert 2.5 kilograms to grams. Convert 2.5 kilograms to grams, and then applying the formula above, we say 2.5 multiplied by 1,000, and that will give us 2,500 grams. That will give us 2,500 grams. So if we multiply that, that will give us 2,500 grams. And then therefore 2.5 kgs is equal to 2,500 grams. 2.5 kgs is equal to 2,500 grams using the formula above. Let's look at another example. Mass is measured in grams and kilograms, and we convert, we say a kilogram, 1 kilogram is equal to 1,000 grams. So how do we convert kilograms to grams? How do we convert kilograms to grams? We do so by dividing the grams that we've been given by 1,000. We do so by dividing the kilograms we've been given by 1,000. So here is an example of a mass conversion. The question reads, convert 1,500 grams to kilograms. Convert 1,500 grams to kilograms. So we'll say 1,500 divided by 1,000, and we will get 1.5 kgs. So that is how we convert. So therefore 1.5 kgs is equal to 1,500 grams. Okay, so you can copy down that conversion. I'll give you a minute to copy it down, and then we'll continue with the other units. I'm sure you've copied everything down. Now let's talk about volume. We said that volume is the amount of space an object occupies. It is the amount of space an object occupies. So volume is normally measured in units like liters and milliliters. So that is how we measure volume. So look at these three beakers. They have different volumes of water in them. The first beaker has a volume of 2 liters. The second beaker has a volume of 7 liters, and the third beaker has a volume of 10 liters. So what we're actually measuring here is the amount of space that is occupied by the water that is inside of the beaker, with these graduations, of course, guiding us in measuring the amount of space that the water is taking up inside the beaker. So which goes to show that we can measure volume of liquids, and we can also measure volumes of other types of particles. We can measure the volume of a gas, because this could have easily been a gas. We can also measure the volume of a solid. So any amount of space that is taken up by an object, we call that the volume. Now, volume is measured in centimeter cubed and in decimeter cubed. So now I've talked about 4 types of unit. The first one is liters, the second one is milliliters, and the third one is centimeters cubed, and the fourth one is decimeters cubed. Okay, you can also say cubic centimeters or cubic decimeters. So volume is calculated by measuring the length, the width, and the height of an object. So this is a case where we're talking about your non-liquid substances. So we measure it by multiplying the length, the width, and the height of an object. So that is how we calculate volume. Let's look at this diagram here, just as a refresher to what exactly is the width, what is the height, and what is the length. So the length is the longest part of this is the length of the cube, and then this is the width of the cube, and then this is the height of the cube. So we're saying width multiplied by length and multiplied by height. So that is how we calculate volume. So let's move on to the next slide. So a liter, if we talk about 1 liter, a liter is the space inside a cube that is 10 centimeters wide, 10 centimeters long, and 10 centimeters deep. So if we look at this cube, it's 10 centimeters wide, 10 centimeters long, and 10 centimeters deep. So that is 1 liter. Think of a carton of milk. Think of a carton of milk, that long-lasting milk. You see, it's in a box, but then we say it is 1 liter of milk. Also think of a juice box or a box of any other beverage. We say it is a liter. So what exactly are they calculating there? They are calculating the length, the width, and the height of that box to give you the end result of a liter. So when calculating volume, 1 centimeter multiplied by 1 centimeter multiplied by another centimeter gives you a centimeter cubed. A centimeter cubed is the same as saying 1 milliliter. So you can interchange those. Those are equal. 1 milliliter is equal to 1 centimeter cubed. 1 milliliter is equal to 1 centimeter cubed. So that means that 10 centimeters multiplied by 10 centimeters multiplied by another 10 centimeters is equal to 1,000 cubic centimeters, and which equals to a liter. So 1 liter is equal to 1,000 cubic centimeters. 1 liter is equal to 1,000 milliliters. So that is the calculation. So let's do an example on how to calculate the volume of a rectangular prism. So here's a rectangular prism here that is 8 by 12 by 6. So we're going to calculate the volume of this rectangular prism. So the formula to calculate volume, remember grade 8, is length multiplied by width multiplied by height. That is how we calculate the rectangular prism's volume. So let's calculate this one. So we're going to say the length is 12 centimeters multiplied by the width, which is 6 centimeters, and multiplied by the height, which is 8 centimeters. So we're going to say 12 multiplied by 6 and multiplied by 8, which gives us a volume of 576 cubic centimeters. Why are we saying cubic centimeters? Remember, the unit that we're using in this case is centimeters, and we've multiplied 1, 2, 3, and then we end up with cubic centimeters. Now, our second example. This is the other way around. We're doing a conversion now. So how do we convert 1,487 milliliters to liters? How do we convert it? Remember, we said a liter is equal to a milliliter divided by 1,000. So we're going to divide 1,487 milliliters by 1,000 to end up with a volume of 1.487 liters. So that is how we do the conversions. So I'm also going to give you a minute to copy down this example. Welcome back. I hope you've copied down the example. Next, we're going to move on to density. We're going to move on to density next. So we defined density as the amount of mass in each volume of matter. The amount of mass in each volume of matter. What exactly does that statement mean? Let's find out. So density of a material actually describes the amount of mass in each volume of that material. Look at box A and box B. Study them carefully. These boxes are of the same size. They have the same length, the same width, and the same height. They are of the same size. But if you look at these boxes closely, the amount of material inside of the box is different. Remember, we said we calculate volume by multiplying the height, the length, and the width. So if I say these two boxes have the same height, length, and width, we mean the volume of these two boxes is the same. So the volume of the two boxes is equal. Now, if you look at these boxes, if you study these boxes, especially what is inside of the box, you can tell that the amount of material inside the box is different. Can you see? It's quite different. So the particles in block A are spaced further apart than the particles in block B. You can see these ones are spaced further apart in box A, and then in box B, they are much packed together, they are closer together. So what exactly does that mean in terms of density? So as a result of the arrangement of the particles within the box B, within the box, these two. So block B, which is this one, is denser than block A, as it has a greater mass given to a greater mass for the given volume. The volume is the same, but the amount of mass or the amount of particles that are inside the box are different, which means B has a greater mass in comparison to A, which also means that B is denser in comparison to A, although they have the same volume. So if we look at iron and cotton, in this picture, they have the same mass, but their sizes are different. The 1 kg of iron, when you look at its size physically, it is quite smaller. But the 1 kg of cotton, when you look at its size physically, it is larger, it is bigger. But the masses are the same. Now, what does that mean? So this is because the iron particles are actually more closely packed together and more dense in comparison to the cotton. So they may have the same amount of mass, but their sizes are different. Because of the way that the particles within these two are packed. The ones in iron are packed closer together, and the ones in cotton are a bit more spaced. So which means that iron is actually more dense. Let's look at these three. We've got 1 cubic centimeter blocks of wood, water, and iron. 1 cubic centimeter blocks of wood, water, and iron. What did we say? We said cubic centimeter is actually a measure of volume. So these are our volumes. So we have a volume of 1 milliliter or a cubic centimeter of wood, a volume of 1 cubic centimeter or a milliliter of water, and a volume of 1 cubic centimeter of iron. They all have the same volume, but let's look at the mass. So the mass is written just underneath each of these cubes. So wood has a mass of 0.5 grams, water has a mass of 1 gram, and iron has a mass of 8 grams. Their masses are different, but their volumes are the same. Let's talk more about these blocks. So all these blocks have the same volume, but the iron block is the heaviest. It's heavier than both the wood and the water. So the iron block is quite heavier. This is because the iron particles, there are more iron particles within this 1 cubic centimeter block. there are more iron particles, because iron particles are quite closely packed. They are very, very, very closely packed. So which gives us a heavier mass. It has the heaviest mass amongst the three. So it may have the same volume, but the particles are spaced, are packed, tightly packed in that volume more than in the water block and in the wood block. Let's move on. Now we're going to do an activity just to illustrate or to demonstrate that particles or materials can be of the same volume, but they will have different masses and densities. So we're going to compare the density of different materials. So for this experiment demonstration, we're going to need air, water, sand, flour, and 4 styrofoam cups. And we're going to pour equal amounts of these materials into labeled cups and then compare their density by hand, by use of hand. So I'm going to be checking using my hand which one is more heavier than the other. So we're going to take a break to bring in our materials, and then we will continue with the demonstration. Welcome back, learners. So I've collected the different materials that we're going to use for this experiment. I've collected sand, air, flour, and water. So I'm going to be checking their mass by hand and then rearrange them from the heaviest to the lightest. Okay, so first I'll check the mass of sand. It's pretty heavy. Air, it's very light. Flour and water. Let me double check these two. Okay, so in order from heaviest to lightest, there. So the heaviest is the sand, followed by the water. Then next we have flour, and then the lightest is air. Then the lightest is air. So now let's go back to the slide and talk about what we have observed. So you're supposed to tabulate the contents of the cups from the lightest to the heaviest. From the lightest to the heaviest. So we have to tabulate these from the lightest to the heaviest. So we have a key that we're going to use. The key that we're going to use is actually a series of numbers from 1 to 4. 4 will represent the heaviest, 3 the second heaviest, 2 the third heaviest, and 1 the lightest. So that is our key. I'm going to pull up a table there, and I'm going to give you just 2 minutes to complete that table, and then we'll complete the table together. Don't forget to send your responses to 082 760 and 2630. So let's complete that table. Welcome back, learners. I hope you have sent your responses to 082 760 2630. So let's fill in the table together. We said the key ranges from 1 up to 4, 4 being the heaviest, 3 being the second heaviest, and 2 being the third heaviest, and 1 being the lightest. So we are arranging these contents in increasing masses: 1, 2, 3, and 4. So which one was the lightest? Remember, we're measuring from the lightest to the heaviest. If you wrote air, You are correct. And which one was the second lightest? Which one was the second lightest? If you wrote flour, you were correct. And then the third one is water. It was the second heaviest. Water was the second heaviest. And then we're going to write 4 under sand. Sand was the heaviest. So if we're counting from lightest to heaviest, air, flour, water, and sand. If we're counting from light to heaviest, air was the lightest, followed by flour, then water, then sand. Air was the lightest, followed by flour, then water, then sand. Let's move on to the next slide for our questions. And we're going to draw our conclusion from the second question. We're going to draw our conclusion from the second question. So I'm going to give you a minute to answer these questions, and then we'll discuss the results together. Welcome back, grade 8. So let's answer the questions together. What did you observe about the volume of the cups? What did you observe about the volume of the cups? The volume of the volume is the same. The volume is the same. So I used identical cups. I used identical cups for this experiment so that the volume remains the same. And I filled up each material into the cup up to the same level. Remember, volume is the amount of space occupied by an object. So by filling up the cups to the same level, I made sure that the volume of the materials is actually the same. So that is how I controlled the volume of the objects inside the cup. The volume of the object. So I fill the cup all the way up to make sure that the volume of the cup was actually equal. And secondly, what conclusion can you make about their density based on your observation? So basically, what is the conclusion here? So the density is not equal to volume, as the volumes are the same, but the densities are different. Why are we saying the densities are different? Remember when we were measuring the masses, when we're measuring the masses of the cups, they were different. We actually graded them from the lightest to the heaviest, air being the lightest, followed by flour, then water, then sand. So their masses, or the way the particles are arranged inside of these different materials, we ended up with different masses from heaviest to lightest. So we can actually draw a conclusion that the density is not equal to the volume, but even though the volumes are the same, actually the densities are different. So we're going to continue with density. So in a substance that has a higher density, the particles are actually more closely packed together. If we look at sand, sand was the heaviest in our illustration. So sand has its particles more closely packed together, as it was the heaviest. So the density of a material is described as the amount of mass in a certain volume of a material. The volume in the cups was all equal. The space occupied by all of the materials was equal, as I filled it up to the exact same level. So the space was equal, so we had the same volume, but the amount of mass within that volume was actually different. So the formula for density is the mass per unit of volume, and it is written as follows. We say density is equal to mass over volume, where P is equal to M over V. What does P stand for? P stands for the symbol for density, and the unit is mass. The unit is grams per milliliter or grams per cubic centimeter. So that is the unit for density. And then M is the symbol for mass, of which the unit is grams. And then V is the symbol for volume, of which the unit is milliliters or cubic centimeters. So this is the formula for density. So how do we calculate density? How do we calculate density? So here's an example. So the density, what is the density of a cube of sugar with a mass of 11.2 grams, measuring 2 centimeters off on each side? Remember, cubes have the same measurement on all of their sides. Let's look at the cube. So there is the cube of sugar with 2 centimeter height, 2 centimeter length, and 2 centimeter width. Now, so how do we write the solution? How do we do this calculation? So the mass is 11.2 grams. So that is the information we've been given. We've been given mass, and we've been given a hint of how to calculate our volume. So if our mass is 11.2 grams, our volume, we multiply 2 by 2 by 2, which will give us 8 cubic centimeters. So now we have our mass and our volume. Let's calculate our density. Remember, mass over volume, or mass divided by volume. So we say 11.2 grams divided by 8 centimeter cubed to give us 1.4 gram per centimeter cubed. Okay, I'm going to give you a minute to copy down this example before we move on to the next slide. Welcome back, grade 8. I hope you had enough time to copy down this example. So some materials are actually heavier than others because of their different densities. And some materials actually have a lot of mass in a small space, and others have smaller space. Others have a smaller amount of mass in the same space. So actually, if you remember that wood water cube example that I gave earlier, where we have a cube of iron being the heaviest amongst the three, although all of them had the same volume. Now, so this is because of the particles and what they're actually made of. So some materials have small light particles, and their particles might be spread out than in denser materials. If we look at flour and water, you would expect the liquid to be lighter than the solid, wouldn't you? But the particles in flour are actually more space than the particles in water, meaning water is actually more dense compared to the flour. That's why the flour was actually the second lightest of all the materials that we were checking their masses, because its particles are actually more spread. There are more air spaces in between the wheat flour particles in comparison with the spaces in between the water. Now I've got an activity here and I'm going to give you 4 minutes to complete the activity. If we read the questions, the first one is what is the relationship between density, mass and volume? The second question reads what is the unit of mass? And the third question is how does mass affect density when the volume of objects remain the same? And how does the volume affect density when the masses of objects remain the same? So I'm going to give you 4 minutes to complete this activity. Welcome back, grade 8. Let's answer the questions together. So the first question is, what is the relationship between density, mass, and volume? So density is the mass that can fit into a certain volume. So this is the relationship. This is how they are related. So the mass that can fit into a certain volume. Remember, if we're measuring the volume of a container, for example, we measure the length, the width, and the depth. So The mass that we can fit in there, in that container, is actually the density. So it is the mass that can fit into a certain volume. So what is the unit of mass? So we use grams and kilograms. And how does mass affect density when the volumes of the objects, when the volumes of the objects remain the same? So the heavier an object is, the higher its density will be. The heavier an object is, the higher its density will be. Remember, when we're talking mass, we're talking how these particles are arranged, how packed, closely packed they are, or they have huge spaces in between them. That is why air had the lightest mass. When we checked it with we checked it by hand, it was the lightest, and sand was the heaviest, because the particles are actually closer together. There are fewer air spaces between the sand particles in comparison to the air particles. So how does the volume affect density when the masses of objects remain the same? So the bigger the volume of an object, the lower its density will be. The bigger the volume of an object, the lower its density will be. As long as we are increasing space, volume is the space occupied. Volume is the space occupied. So if we are increasing the space in between the particles, the density will actually be lower. The density will actually be lower. Here's our second activity. In this activity, we're going to be doing calculations. And I'm going to give you 5 minutes to do this activity, and then we will go through the solution step by step together. Okay, welcome back, grade 8. Let's go through the solutions together. So the first question says you have a 500 gram block of butter at home. You found out its volume is 555 milliliters. What is the density of the butter? So this is how you're supposed to calculate the solution. So the mass is 500 grams. The volume is 555 milliliters. So we use the formula density is equal to mass over volume, where we say 500 grams divided by 555 milliliters, and then we get an answer of a density of 0.9 gram per milliliter. So that is the answer there. And then the second calculation was you have a large glass marble with a density of 0.25 gram per milliliter, and you want to find out what the volume is. You measure the mass and find it to be 50 grams. So what is the volume? So the solution, you check what you've been given. You've been given mass, you've been given density. So how do we calculate the volume? So we still go back to the formula for density, which is 0.25 grams per milliliter is equal to 50 grams over an unknown, the unknown being volume. So we multiply 0.25 grams multiplied by the unknown to give 50 grams, and then we go on to swap them around and divide the density. We divide the mass by the density to give us 200 mils. So the volume is 200 mils. And then the third question is gold bars each with a mass each weigh a mass of 250 grams. What is the mass in kilograms? Remember we said 1,000 grams is equal to 1 kilogram. So meaning if we divide the number of grams by 1,000, it will give us the kilograms. So if we divide 250 grams by 1,000, it will give us a mass of 0.25 kgs. So the mass of the gold bar is 0.25 kgs. And then the fourth question, which is an object has a mass of 57 grams and a volume of 228 cubic centimeters. Calculate its density. So we go back and check what information we've been given. We've been given a mass, 57 grams, and we've given volume, 228 cubic centimeters. So how do we calculate density? We say mass over volume. Mass is 57 grams divided by 228 cubic centimeters, and then giving us a density of 0.25 grams per cubic centimeter. Here I'm just showing you that we can have milliliters, we can be given volume in milliliters, and we can be given volume in cubic centimeters. So we've reached the end of our lesson, so we're going to summarize today's lesson. What did we learn today? We learned that density is the amount of mass in each volume of matter. We also learned that volume is the amount of space an object takes up. We also learned that mass is the measure of the amount of matter in an object, and the units for mass are grams and kilograms. The units for volume are liter and milliliters, also cubic centimeters and cubic decimeters. And the formula for density, for calculating density, is mass over volume. And the units for density are grams per milliliter, or you can also add grams per cubic centimeter. Right. In our next lesson, we're going to be learning about these. We're going to be learning about density and the states of matter. Okay, grade 8. Thank you very much for joining me in this lesson. Do not forget to sanitize, keep your social distance, and wear your mask. Until next time, bye-bye.